Hi, I just want to talk to you today about the Ready Practice and Problem Solving book that you're working on, pages 19 and 20. And I wanted to talk to you a little bit about some questions I saw on page 20 just to clarify. The one I wanted to start with is number 6. Number 6 has this phrase in it, then evaluate the expression. So evaluate the expression is another way of saying find the answer. So when it's saying write an addition expression that is equivalent to 65 minus 79, then we have been doing that a lot in class where we've taken subtraction problems and written an equivalent addition problem. And then we find the answer. So that's all they're asking you to do, is to take that subtraction problem, write an equivalent addition problem, and we have 3 steps for that we put in our reference notebook, and then just find the answer. This right here, number 7, comes directly from what we wrote in our reference notebook a couple of days ago. We have 3 steps. They begin with keep, change, and flip, if that helps you to remember what they're asking you to do there for number 7. In number 8, it says write an absolute value expression to represent the distance between -1 and 6 on a number line. Then evaluate the expression. So what they're asking you to do is use absolute value. So I'm going to draw an absolute value bar. Oop, that's not very straight, but imagine that was a straight bar. I'm going to draw another one. And I'm going to put in there -1 and 6. So if we're finding the distance between -1 and 6, to find the distance, I am just think about it. If I was finding like how far apart something is, if I was finding the distance between 2 and 5, or the distance between 10 and 30, to find the distance, you subtract. So I'm going to actually subtract these numbers to get a distance, but distance is always positive. So to do this problem, I'm going to do the subtraction problem inside the parentheses first, and I have -7. Now to get -7, to get from -1 minus 6 is -7, I could either think about it like I'm on the number line, I'm starting at -1, I'm going 6 spaces to the left, or you could think about it as keep, change, flip, and that's really -1 plus -6, or however you're able to think about it, it is -7. Then after I found the answer to the problem inside the absolute value bars, I put the absolute value bars around the answer of -7, and then I evaluate and say, what is the absolute value of -7? So the absolute value of -7 is 7. So that means that should be and if you think about it, how far apart are -1 and 6 on the number line? Well, they're 7 spaces apart. So that is why the answer is 7, and that's how you do it with absolute value. In the last problem, number 9, it says the expression x minus 4 represents a negative integer. What integer could x represent? So what they're saying is, if I take x, a number, any integer, it could be any integer, and I subtract from it 4, I get all different possible answers. So if I use whatever I use for x, whatever number I pick for x, like 10, if I do 10 minus 4, would that be a negative number? No, 10 minus 4 is 6. So I'm saying I could pick anything for x, but in this case, I need to pick a number for x so that after I subtract it by 4, that the answer I'm getting should be negative. So what it's asking you to do is come up with the different numbers that you could use so that when you subtract 4 from them, your answer is still negative. And find a way to represent all those numbers. Number 9 is kind of tricky, but it does make us think, because I'm like starting with an integer and I'm taking 4 away, and the answer needs to be negative. So what integers would work for that? So it's tricky, but it's a good thing to think about. Okay, so that was a little bit of help from 6 through 9. If you have any other questions, document them on your homework, and then you can ask them tomorrow in class, or you can ask me before school if you come in during homeroom. That would be fine too. Anyway, I hope this video helped you some in navigating through your pages 19 and 20. Thanks.